So looking at question 3, so the information we're going to take from this is that the length of the line segment AB is 4 root 5, so that's that length of a line here. And what's the question asking us? It's asking us to find the length of the radius K. So they're getting us to find the length of the radius of that circle. What I'm going to draw in on my circle is the radius length, and I'm going to draw it from the point C, which is the center, out to the edge of the circle, and I'm going to connect it to A. Now we could connect it to B if we wanted to, but that's basically what they're asking us to find, the length of the radius line. You can see there that I've basically created a triangle. The angle here where we have our radius line meeting our chord is always a 90-degree angle. And another piece of information we know about a chord is that when it hits the radius, it divides the chord in 2 equal halves. So that point D is basically the midpoint of the line segment B. So I'm going to draw out that triangle. So we're going from point A to point C. So there's a lot of information there, but hopefully we can figure all that out. And we're going over to the point D. And the distance from A to D is half the length of AB. So that's going to be 4 root 3 divided by 2, which is 2 root 3. I've created a 90-degree angle. And what's the distance from C to D? Well, I don't know that actually, so I might go off and find this length here in 1 second, the distance from C to D. And what are we asked to find? We're asked to find the length of the radius, which is this length of a line here, and I'm going to call that R for radius. So I'm going to hopefully use Pythagoras' theorem in a couple of minutes, but before I use Pythagoras' theorem, I need that other length, CD. So I'm going to go off and find that using my distance formula. So from my log tables, I have the distance as x2 minus x1 all to be squared plus y2 minus y1 all to be squared in the square root. I'm getting the distance from A to D, and I have the point, C to D I should say, and the point C is 1 minus 2, and the coordinate of D is 3, 2. And labeling those as my x1, y1, x2, y2, and filling them in then to my distance formula. I have 3 subtract 1 to be squared plus y2 minus y1 all to be squared in my square root. 3 take away 1 is 2, 2 squared is 4, 2 minus minus becomes 2 plus 2 is 4, 4 squared is 16. So the distance from D to C is giving me a square root of 20, which is the same as 2 root 5. So I'm going to come back up to my little sketch here and I'm going to write that in. So I have 2 root 5 here for the distance from C to D. Now I can actually find the length of my radius line using Pythagoras' theorem. My formula for Pythagoras is c squared is equal to a squared plus b squared. C squared must be the hypotenuse, the side across from the 90, so that's going to be my R, my radius. My A and my B are the other two sides. So it doesn't matter which is your A, which is your B. I'm calling the distance from A to D my A, so that's 2 root 3 all to be squared plus 2 root 5 all to be squared. So that's getting me a radius squared of 4 times 3, which is 12, 4 times 5, which is 20, which is 32. So R is going to be the square root of 32, which is 4 root 2. And if you could scroll back up to the top of the question, it said give your answer in the form A root B. And that's what we've just done. We have it as 4 root 2. Okay, scrolling down now to part B. So B part 1 is asking us to show that the circle C and the circle S touch externally. So it basically looks something like this. So if we do a quick sketch of what's going on here, and if they touch externally, it basically means that if I get the distance from the edge of the circle to the radius for one of my circles, let's call that C, and I get the distance from the edge of the circle to the center of my other circle, S, that is the same distance as me getting the distance from point to point, center to center. So we basically know it so as to prove touching externally, we add our 2 radius, R1 plus R2, and that must give me the distance between the two centers. And if it does, well then they're touching externally. We subtract them then if it's touching internally. So what do we know here? So our first circle, S. So the center of S, let's write down some information here. So the center of the circle S, first of all, is going to be 713. Okay, so we can just read that from the equation of the circle there. And my radius of S is going to be root 25, which is 5. So there's my center and my radius of S. Let's come over now and do the same thing for circle C. So my center of C, now we need our log tables for this. So I have 2g is equal to 4, isn't it? It is, yeah, the coefficient of the x. So 2g is equal to 4. G is equal to 4 divided by 2. G is equal to 2. So minus g is equal to minus 2. And then I need to have my f. So 2f is equal to negative 2, the coefficient of the y. So that's minus 2. F is equal to minus 2 divided by 2. F is equal to minus 1. Minus f is equal to positive 1. So that means then that the center of C is given as minus 2, 1. And now I need to get the radius of C. So radius of circle C. And again, it's given by the log tables formula, g squared plus f squared minus c squared. And I plug in my values for g and f, and I put in minus 2 squared. Make sure we use brackets here because they're negative. And minus my c. My c is the constant, which is negative 95. So that's giving me minus 95, isn't it? It is, yeah. So I need to put in my 2 minuses there. So that's giving me 4 plus 1 plus 95, which is the square root of 100, which is 10. So the radius of C is 10. Kind of stuck for space here. Let's make a bit of room. So that is the 2 radius. What I now need to do is get the distance between the 2 points. So I'm going to get the distance between the centers. So the centers here again are 713 and minus 2, 1. And I'm going to label them then x1, y1, x2, y2. Putting them then into my distance formula, x2 minus x1 all to be squared plus y2 minus y1 all to be squared in the square root. And that's getting me the distance between the 2 radii. And putting in my values, I have minus 2 minus 7 all to be squared plus y2, which is 1 minus 13 all to be squared. Running out of space here, so let's see what that gives us. That gives us the square root of 225, which is a distance of 15 units. So if we come back to the top here, how do we prove that they touch externally? I'm going over here now. It's R1 plus R2 is equal to the distance. My radius 1 is 5, so that's my first value. My radius 2 is 10, and I put that in. That should equal to the distance between the 2 points, which is 15, and it does. 5 plus 10 is 15 is equal to 15, which is therefore touching externally. Okay, not a lot of space there. Scrolling down now to part 2, B part 2. So there are infinite number of circles which touch circle C externally at the same point that S touches C. Find the coordinates of the circle of any of the coordinates of the center of any of these circles apart from the circle S. So there's infinite amount of circles we can have. Different ways we can do this question. First of all, though, let's kind of just sketch what we have just so we can visualize what they're asking us to do. So I've just sketched out my coordinate graph, and now I'm going to draw the circle C. And C has a center of minus 2, 1 and a radius of 10. So what would that look like on my graph here? So I go back -2 up to 1. So there's my center, radius of 10. So I go up 10, brings me to 11. Go back 10, brings me to back here. Let's say -12. Go forward 10 is bringing me up to 8. And down 10 is bringing me to 9. So somewhere down here. And if I was to sketch that then with my circle, very rough here, it's going to look something like that. Okay, well, let's just park it there for a second. My other circle is the circle S, and let's see what's happening with S. S has the center 7, 13 and a radius of 5, wasn't it? It was. Okay, so let's see where that will go on my coordinate graph. So I have my center 7, 13, which is about there, and a radius of 5, so that brings me down to about 8, which is there. 7 take away 5 brings me to 2, which is about there, and 5 to 12 is there. Okay, so again, it looks something like, and all I'm trying to get to do here is just where they, okay, that's not it, where they basically touch the circle. And again, it's just a rough sketch here. All I'm trying to do is get that coordinate here. And all I want to do is visualize that. And that's the point where the circle C and the circle S are meeting. So this is just a very rough sketch so I can visualize this. And they want me now to find the equation of any other circle that goes through that point. So just zooming out for a second. So basically another circle could be this one. Or it could be this one. Again, just very rough sketches, but that's what they're asking us to find. Now what I want you to visualize there is that both of these centers are going through a line. So if I draw a line between the two centers of these circles, see that green line here? Now those two centers also go through that point of contact, and remember that we know that the distance from the center to the edge of the first circle is 10, and the distance from the edge of the circle to the other center is 5. So that's the 15 that we got in B part 1. And what I know though is that any other circle will also have a center that is on that green line. So basically what I want to do is find the center of a circle that basically sits on this green line. And in order to do that, or how to find that coordinate, what I'm going to do is I'm going to get the equation now of this green line using my two centers. That's the first thing I'm going to do. And then separately, so let's just highlight that actually. So I'm going to get the equation of this yellow line between the two centers. Separately then, I'm going to get the equation of the tangent, which also goes through that point. And I'm going to use simultaneous equations to find that point in blue. So that's what I'm going to do next. So first of all, let's find the equation of that yellow line. So I'm using the two centers, -2, +1, and 7, 13. Labeling those x1, y1, x2, y2, using my slope formula for my log tables. And subbing that in, I get 13 subtract 1, 7 minus 2, which is giving me a slope of 4/3. So that's the slope of the line between the two centers. And now I'm going to form the equation of the line. So my y minus y1 equals mx minus x1. And I can use either one of the 2 points as my x1 and y1. So I'm going to sub in the 1 as my y1. And I'm subbing in -2 as my x1. And then if I multiply across by 3, that's giving me 3y minus 3 is equal to 4 times x plus 2, which gives me 3y minus 3 is equal to 4x plus 8, which tidies up as 4x minus 3y plus 11 equals to 0. So that's the equation of the line between the two centers. Now what I want to do is I want to find the equation of the line that goes between the two circles, so the tangent to the point of contact. So in other words, the equation of this blue line. And in order to get the equation of a tangent, between the two circles, basically what I want to do is I subtract the two equations of the circles from each other. So that's what I'm going to do now. So I know the equation of one of the circles is x squared plus y squared plus 4x minus 2y minus 95 is equal to 0. The other equation is in the form of x minus 7 squared plus y minus 13 squared equals 25. When I multiply that out, I'm getting x squared plus y squared minus 14x minus 26y plus 193. So I'm basically just squaring out the brackets. And then if I subtract them from each other, or multiply across by minus 1, basically changes these signs. My equation of the common tangent is then giving me, well, they'll cancel, 18x plus 24y minus 288 equals to 0. So that's the equation of that blue line. So let's just highlight what we have. That's the equation of the blue line. That's the equation of the yellow line. Now I want to find out where they intersect with each other. So I'm going to use simultaneous equations to find the point of contact. So I'm going 18x plus 24y is equal to 288. Simultaneous equations with 4x minus 3y is equal to negative 11. Multiplying the bottom by 8 is giving me 18x plus 24y is equal to 288. And on the bottom now, when I've multiplied by 8, is 32x minus 24y is equal to minus 88. The positive 24y and the negative 24y will cancel. 18 plus 32 is 50x is equal to 200. So that means that x is equal to 4. Now I don't actually have to solve for y, because let me show you on the picture. The 4 that we found is basically here. So if I draw that line up again, this is only a sketch, so it's here. Let's draw a bigger point. I've basically just found the 4 there. Now we don't need the y, because all I need to do is that the point that I pick must have an x value greater than 4. Because if I use anything less than 4, I'm basically coming back inside the circle C. So my value for x in my equation of the new circle must be bigger than 4. Okay, so that's why we did out the simultaneous equations, just to get that value of 4. So basically what that basically means now is that if x has to be bigger than 4, I can look for the equation of any circle now. So I'm just going to assume, so let x equals to 6, as long as it's bigger than 4. And if x is bigger than 4 and I'm letting it equal to 6, I basically need to find its corresponding y value. Again, remember, it must sit on the line 4x minus 3y plus 11. That's the equation of the circle between the two centres. So if I sub in x as 6, I should solve for y. So I'm subbing in 6, so 4 bracket 6 minus 3y plus 11 is equal to 0. And I get minus 3y, 6, 12, 18, 24, 35 equals to 0. So minus 3y is equal to negative 35. So in order to solve for y then is equal to minus 35 divided by minus 3. Minus divided by minus is positive 3 into 35, just stays as 35 over 3. So therefore, one sample coordinate for the center of a circle is x as 6, I should say, as long as I pick it bigger than 4. So I picked 6, and y as 35 over 3. So different ways of doing that question, but all will have an x value bigger than 4. And that's why I did all that complicated bit of work at the start to make sure that that value is true.